Hello students, we are discussing infinite series. Under that, introduction to infinite series. So first we discuss the sequence, and from sequence how we able to define the infinite series with some properties of infinite series. In this chapter we will learn about the convergence and divergence of an infinite series. There are various methods to test the convergence and divergence of an infinite series, such as comparison test, ratio test, Cauchy nth root test. So these are the different techniques to test whether the series is convergent or divergent. First, we'll discuss what is the sequence. An ordered set of real numbers as u1, u2, u3, un is called a sequence and is denoted by with this notation in parenthesis un. So this u1, u2, u3, un, these are nothing but our real numbers and it is a order set. So if we have 1, 2, 3, 4, these are the real numbers and they are ordered. So such is called as a sequence. If the number of terms in a sequence is infinite, it is said to be infinite sequence. Otherwise, it is a finite sequence. One definition under the sequence, monotonically increasing. So when we'll say that a sequence is said to be monotonically increasing if un plus 1 is greater than or equal to un for each value of n. So this condition says that every next number is greater than or equal to previous number. So see in the example 1, 2, 3, 4, 5. These are the real numbers and they are in ordered as the next number 2 is greater than previous number 1. Similarly 3 is greater than the previous number 2 and so on. So this we call it as a monotonically increasing sequence. Next definition, a sequence is said to be monotonically decreasing if un plus 1 is less than or equal to un for each value of n. So this condition says that every next number is less than or equal to previous number. So see in the example, every next number, that is 1 by 2, is less than the previous number, that is 1. Again 1 by 3 is less than 1 by 2. 1 by 4 is less than or equal to previous number 1 by 3. So this we call it as a monotonically decreasing sequence. Third definition under the sequence, a sequence is said to be alternating sequence if the terms are alternate positive and negative. See in the example, this is a sequence. It is in ordered real numbers. First number is positive 1, second number is negative minus of 2, third is positive, fourth is negative. So we have here in the example alternate sign with positive, negative, positive, negative. So we call it as a alternating sequence. From the sequence, now we'll go ahead how it become an infinite series. See, If u1, u2, u3, un is an infinite sequence of real numbers, so this must be a infinite sequence as we have discussed the sequence. If it become infinite sequence of real numbers, then the sum of the terms of the sequence. So if we'll take their addition of terms, then it is called a infinite series. So infinite series is defined from infinite sequence of real numbers if we'll take their addition of terms. The infinite series u1 plus u2 plus u3 plus un up to infinity is usually denoted by summation of n equals to 1 to infinity un or summation of un. So this is a short notation, summation of un. So this become infinite series. Some properties of infinite series: the convergence or the divergence of an infinite series remain unaffected. It remain unchanged by addition or removal of finite number of its term. So if we'll add or if we'll remove some terms from an infinite series, then its convergence or the divergence remain same. Again, by multiplication of each term with a finite number. So if we'll multiply each term with a finite number, then the convergence or the divergence remains same. One more property: if two series summation of un and summation of vn are convergent, then in the summation, if we'll take their addition, un plus vn is also convergent. So two independent series, if they are convergent, then if we'll take their addition, then it is also a convergent series. Thank you. Thank you all.